Introduction: From Metal to Plastic. In 1951, Remington Rand introduced UNIVAC 1 with bronze alloy metal magnetic tape on 8-inch metal reels, running on its uniservo tape units, the first commercial computer with magnetic tape reel storage. In 1952, IBM introduced its first magnetic tape reel unit, the 726, which used cellulose acetate tape, which was much lighter and easier to use than UNIVAC's metal tape. PET and Mylar. In 1941, PET, or polyethylene terephthalate, a polymer resin, was invented at Calico Printers Association in the UK. PET was later developed into a product called Terylene at Imperial Chemical Industries, UK. In 1948, the DuPont Company purchased rights from Imperial Chemical. After further research and development, in 1952, DuPont introduced Mylar, a stable, reliable magnetic storage medium tape. DuPont patented its Mylar brand. IBM soon replaced cellulose acetate magnetic tape with Mylar tape film on its 727 tape unit. Other computer makers quickly followed suit. Today, widely used in audio, video, and other applications. Mylar is a product of a joint venture called DuPont Teijin Films. In October 2017, the multinational Indorama Ventures announced plans to acquire DuPont Teijin Films. The following presentation begins at 1952. The IBM 726 Magnetic Tape Unit. On May 21, 1952, IBM announced the IBM 726 Magnetic Tape Unit. Reel-to-reel magnetic tapes provided a high-speed method of processing greater quantities of data than were previously possible through either cathode ray tube, CRT, or drum storage technologies. The IBM 726 unit could read or write at a rate of 12,500 digits per second and a capacity of over 2 million digits per tape. The 726 used an oxide-coated, non-metallic tape, approximately 1/2 inch wide. This was in contrast to the 1951 Remington Rand UNIVAC tapes, which were constructed of metal oxide bronze alloy. Information on the 726 tape drive was recorded in 6 parallel channels. A 7th channel was reserved for error checking. Tape density was 100 bits per linear inch. The 726 tape drives were used with the IBM 701 data processing system and other early IBM machines. The 726 was eventually replaced by the more advanced 727 and 729 tape drive units. The IBM 727 Magnetic Tape Unit. On September 25, 1953, IBM announced the IBM 727 Magnetic Tape Unit. It provided large capacity storage and a high-speed input. In 1952, IBM had announced its first commercially available scientific computer, the IBM 701. The 701 was the first in the pioneering line of IBM 700 series computers, which later included 702, 704, 705, and 709. Up to 5 727 units could be connected to a single IBM 701 computer. Additional 727s were possible by adding additional circuits. Recording density was 200 bpi. Tape could be read both forwards and backwards at 75 inches per second. Read-write speed was 15,000 characters per second. With an attached card reader and control unit, the 727 could transfer punch card data to tape at 250 cards per minute. Tape-to-card transfers were performed at 100 cards per minute. On October 1, 1954, IBM introduced the new 705 data processing system, with the 727 tape unit as a compatible device. This vintage film clip from 1957 shows an IBM 705 installation with the 727 style tape drive.
An IBM 705 system is utilized to process selected data generated by the agency's mission. Let us examine the characteristics of this particular system. Data and instructions on punched cards can be fed from a card reader directly into the memory of the central processing unit, which in this case is a magnetic core device. Data and instructions on magnetic tape, in turn, can also be fed into memory. From this medium, data can be fed into the ADPS at a speed of 15,000 characters per second. Magnetic tape has the added advantage of affording storage for large quantities of data in a small space. The data on 25,000 punch cards can be recorded and stored on one 2,400-foot reel of magnetic tape. The operator pays particular attention to this setup phase to ensure that the processing will be executed as programmed.
Although the IBM 728 tape units, seen here, were physically similar to Model 727 units, they were designed to different specifications for use with the IBM Sage computer, also known as the ANFSQ-7.
They must be put in a form the computer can accept. Punched cards, thousands of them. Cards then enter a high-speed computer for processing. While all this is going on, the computer is receiving instructions from previously recorded tapes. The result is a new magnetic tape recording containing the radar data for Sage STP problems. Periodically, problem tapes are checked in the FSQ-7 computer to ensure that the problems are compatible with the operational programs for the Sage system. The SSTP problem tapes are prepared for shipment to Sage direction centers throughout the country. At the start of the exercise, the problem tape begins to feed simulated long-range radar data into the memory of the computer. The synthetic data is processed by the same programmed instructions that are used in normal operations.
The IBM 729 magnetic tape unit. The 729 was a highly successful IBM tape drive used in the late 1950s up through the 1960s. The 729 used 1/2-inch tape up to 2,400 feet long on reels up to 10 1/2-inch diameter. To allow rapid tape acceleration, which contributed to fast data access, long vacuum columns were placed between the tape reels and read-write head to absorb sudden changes in tape speed that could otherwise break the tape. Initial tape speed was 75 inches per second. Early units had a recording density of 200 CPI, which allowed a 2,400-foot reel to hold about 50,000 punch cards worth of data, or roughly about 3 megabytes. Numerous 729 models were introduced as technical improvements were made over its lifespan. The 729 Model 1 was introduced for IBM 709 and IBM 705 Model 3 computers. This early 729 tape unit looked identical to the IBM 727 tape unit and used vacuum tubes. The 729 Model 2, which utilized transistors, was introduced for the IBM 7000 series computers, and it introduced a new cabinet style.
A new automated process for manufacturing magnetic core memory devices made it possible for low-cost computer systems to efficiently sort thousands of records. Hard input units, tape drives, and printers now could offer for the first time the speed and versatility needed by large commercial users. The combination of these advances brought about a second generation of computers in 1960 with the delivery of the 1401 system. This second computer generation, with its vast improvements in processing speed and capacity, made extensive use of tape input-output systems, especially for record-keeping jobs. Year-to-date records on tape could be read into or out of computers at the previously unheard-of rate of 41,000 characters per second. Besides speed of access, tape could store an enormous amount of information for its size in comparison with punched cards. A standard reel holds 2,400 feet of 1/2-inch wide tape and can contain data equivalent to about 400,000 fully punched cards, or 200 card boxes filled with punched cards. We had the 1400 family for commercial applications. The 7000 family was mainly used by the scientific community. And a new 7740 computer family was developed to do message switching applications. The former card system carried with it 46 drawers of advance cards, 23 drawers of accounts receivable, and 32 drawers of name and address cards, which the 1401 replaced with less than one rack of magnetic tape. The reduction of procedural steps is equally dramatic. Customer billing on the old card-based equipment involved 21 separate machine passes. The 1401 system did the same jobs in just 7 machine steps.
1954, the IBM NORC. IBM's Naval Ordnance Research Calculator, or NORC, was a specially designed, one-of-a-kind, high-speed computer built for the U.S. Navy. NORC used 9,800 vacuum tubes, over 1,000 diodes, and executed 15,000 calculations per second. NORC had 8 magnetic tape units, similar to the units on the IBM 701. However, the reels, controls, and cabinet of the tape units were unique to NORC's design. These ultra-high-speed units could read 71,000 characters per second from a single tape. NORC was built between 1950 and 1954 at the Watson Scientific Computing Laboratory, Columbia University, and the Navy Computation Laboratory at Dahlgren, Virginia. Many advancements achieved during its construction were incorporated into later IBM computers. Delivered to the U.S. Navy in December 1954, NORC remained in service until 1968.
General Electric Company. GE was one of the 8 major computer companies of the 1960s. General Electric was formed in 1892 by the merger of Edison General Electric Company of New York and Thomson Houston Electric Company of Massachusetts. Its first large-scale digital computer contract was the agreement to build 32 ERMA machines for Bank of America. ERMA stood for Electronic Recording Machine Accounting. It was a pioneering computer development project run at Stanford Research Institute from 1950 to 1955 under contract with B of A. GE also contracted with National Cash Register Company, NCR, to build the NCR 304 computers. The ERMA and the NCR 304 were GE's 2 major computer contracts in the 1950s. GE selected the successful AMPEX Corporation as the supplier of the magnetic tape units for these and many other computers in the GE product line. Throughout its history, GE made significant contributions to the early computing field, including the 1952 ORAC, one of the earliest digital computers, and work on the Dartmouth time-sharing system, DTSS, in the 1960s. AMPEX. AMPEX Data Systems Corporation, as it is known today, has an extensive and impressive history of technical innovation and influential digital recording products. AMPEX drives were also used in the National Bureau of Standards CHAP computer, the Atlas computer at Chiltern, UK, early CDC 1604 computers, and many more.
Merchandise National Bank is proud to be among the first in the nation to install an electronic computer, a General Electric 210 system that can actually read the same information you and I can read. Components in our system include the reader sorter, a high-speed printer, the magnetic tape units, the central processor, and the control console. To make sure that we've added just the right amount of iron oxide particles to the line of symbols on Sally's checks and deposit tickets, we test samples on this signal strength machine. The computer system not only reads information, it records all of the vital details on magnetic tape. These ledgers of tomorrow record and store all of the information pertaining to all of the bank's checking accounts. The tape units operate in much the same way as a home tape recorder, but of course they're much faster. Information can be recorded on or read from the tape at the rate of 30,000 characters per second. And presents us with the information read from the checks and deposit tickets in numerical order. Now we're ready to do our daily posting using the transaction tape, which lists checks and deposit tickets in account number order, and a master file tape.
The RCA Bismack computer. In 1951, RCA was awarded a military contract to build the Bismack, a large-scale data processing machine. RCA was an early entrant into the computer field, using its vast resources in early electronics research and vacuum tube technologies. It gained an important foothold in the early 1950s. The first Bismack machine was installed in 1956. The Bismack was a vacuum tube giant. A unique design of the Bismack was the use of hundreds of tape drives connected to a central computer. Permanently mounted tape data could be transferred from tape units immediately, without the need for constant mounting and dismounting individual tapes. Tape station operators controlled the flow of data to the main computer. In 1958, RCA introduced the 501 electronic data processing system. The RCA 501 was a medium to large-scale computer, utilizing all transistor logic. All system operating controls were centralized in a specially designed computer control panel. The 501 also utilized high-speed magnetic core storage. The 501 could accommodate up to 63 magnetic tape units. Other system components included a card punch, card reader, paper tape punch, paper tape reader, typewriter verifier, and other devices. RCA went on to produce other computers, such as the 301 and the 601, and the RCA Spectra 70 line of large-scale computers. By 1971, however, RCA had experienced millions in losses. In September 1971, RCA sold its commercial computer division to Sperry Rand.
It's a remarkable new polyester film called Mylar. High tensile strength, high tear resistance, and high impact strength. In short, Mylar's physical properties make it the strongest of all plastic film under a wide variety of conditions. Today, Mylar is being widely used because it's the only known base film that meets this ideal. And because Mylar is so much thinner and stronger, you can get 50% more tape on a standard reel. Glamorous Mylar metallic yarns are stronger, non-tarnishable, withstand washing, dry cleaning, and pressing. Draperies can take on exciting new effects.